Hey everyone, welcome back. So if you notice, today's aim is something that we've seen before, and is how do we solve linear equations. We're going to be starting our review for our Algebra 2 session, which will be next year for us. Our learning objectives are to isolate variables using inverse operations, solve algebraic equations using the properties of equality, and simplifying algebraic equations using the properties of equality and the distributive property to clear parentheses. Just to recap before we get started in our actual problems, commutative property. So if I gave you these examples, commutative property basically means we want to move things around. So if we were to highlight commute, which is kind of in the word commute, means to move. So if I had 2 times 8, commutative property would basically say 8 times 2. So we're moving things around, but the result is still the same. Same thing applies for addition. If I had negative 4 plus 7, the commutative property would be 7 plus negative 4. All right. Our next property is called reflexive property. Now, the word reflexive, we kind of see the word reflect. So if we were to see a problem like this, a lot of us don't like looking at the problem in this way. So what do? We basically reverse it. So what's on the left side, we would just write on the right. And what's on the right side, we write on the left. Said that backwards, but you know what I mean. All right, so this is basically saying the same exact thing. We just moved it around so it makes it looks better for us. Distributive property. This is going to be very important into what we're going to be doing today. If we see a term on the outside followed by a parenthesis, that means it is multiplication. So we would have to distribute that value or term on the outside to everything on the inside. So if I were to do 3 times x, that's 3x, and 3 times a positive 5, we have to use a symbol in front. That gives us a positive 15. There's a few more examples, so we're just going to go through all of them. We have 2 times x, which is 2x, and then 2 times a negative 7, which is negative 14. So it reads as 2x minus 14. My next one, if you notice, this says negative 5 on the outside. So negative 5 times x is negative 5x. And then negative 5 times a positive 4 is negative 20. And our last one here, we have a negative 6 times x, which is negative 6x. And then we have a negative 6 times a negative 1, which is a positive 6. Remember, negative times a negative is a positive, right? And then if we were to do factoring, it's basically going backwards. So we're basically starting with our second row down here at the top, and then trying to get back to what distributive property looks like. So in this case, it helps for some of us if we were to write everything out to see if there's a GCF. Remember, factoring means we want to break down. So factoring means we want to break it down. Okay, so in this case, our GCF would be a 3x. How do we know that? If we were to break down both of these pieces, I'm going to take the sign in between into consideration after. If I were to break down 3, that's 1 times 3. And then x squared would be x times x. If I broke down 18, I could have 1 times 18. I could do 2 times 9. I could do 3 times 6. And then I have an x. Okay? Now looking at my numbers, what's the biggest number they have in common? They both have a 3. Sometimes they will not have anything bigger than the 1, so just keep that in mind. As well as they both have x's. How many x's do they have in common? They have 1 x in common. So my GCF is 3x. Now I have to rewrite something inside the parentheses. If I have two terms here, which is called a binomial, I must have two terms inside my parentheses. So if I were to divide all my terms by that GCF that we just created, 3x squared divided by 3x is x, and then negative 18x divided by 3x is negative 6. That's what we call factoring. So if I wanted to multiply or distribute this back out, I will get back 3x squared minus 18. All right, so before we get started with the work again, we want to recall about don't call me impossible. When we are solving linear equations, we want to distribute, we want to combine the like terms, then move variable to one side, and then inverse operations to isolate the variable. Now, before we get started with that, our operations, hopefully remember, is PEMDAS. But since we're doing inverse operations, we're going to be using PEMDAS backwards. So that means we want to do our addition and subtraction first. Then we're going to do our multiplication and division, then exponents, and then parentheses. But for the most part, these are the only two we're going to be focused on in this lesson. Here's our first question. So it says 34 is equal to 2 times x minus 7. I don't like the way it looks, so I'm going to use the reflexive property. So I'm going to do 2 times x minus 7 equals to 34. This looks a little bit more familiar to me. So now I'm going to distribute because there's a 2 on the outside next to a parenthesis. So 2 times x is 2x, and then 2 times negative 7 is negative 14, equal to 34. Next, we want to combine like terms. There are no like terms here. We want to move the variable to one side. It's already on one side. I'm just going to do it with this one, and then hopefully you'll realize to identify sides where the equal sign is, I drew a line so we know that we have our left side and our right side. All my variables that I'm solving for is on my left side already, so I don't need to do anything else. Now we want to do our inverse operations. So remember I said we're going to be doing PEMDAS backwards. So we're going to do adding and subtracting first, and then multiplication and division. So we want to focus on the side where the x is. So on this side, do I have anything that I can move from here? I have a negative 14. Inverse operation is add 14. But remember, anything we do on one side of the equation, we must do to the other. So if I add 14 on the left, I must add 14 on the right. This causes us to cancel. So I'm left with 2x equal to 48. Now, on the side with the x, this is now multiplication. The inverse of multiplication is division. Once again, what I do on one side, I must do to the other. Notice that I did not place the x down in my denominator as well. That's what we're solving for, so we do not write it down below. So now 2 divided by 2 is 1, leaving us with x, or 1x, and then 48 divided by 2 is 24, so x is equal to 24. Our next problem says 4x plus 1 minus 2 is equal to negative 6. First step, we want to distribute, so we have 4 times x, which is 4x, 4 times a positive 1, which is positive 4, but there's more to write. Minus 2 equal to negative 6. From here, we want to combine like terms. Now, before I did not mention it before, but like terms must be on the same side. All right? So in this case, these are like terms because they're just numbers. Like terms mean they must have the same variables, and the same powers, if they don't have variables, then they're considered constants, which means that they are the same, like terms. So we have 4x plus 2, and then on this side we have negative 6. We want to move the variables to one side. Once again, it's already on one side. So now I want to do inverse operations. Same thing like what we did last time. This looks very familiar. Now we want to minus 2. And we're left with 4x, and negative 6 minus 2 is negative 8. Then we want to do divide by 4 because that's multiplication, but what we do to one side, we must do to the other. So x is equal to negative 2. Our last question here, we're going to start it off. We see that this, once again, the negative 6 is attached to this. So I'm going to start off with my 9, but now I'm going to distribute the negative 6. So negative 6 times x is negative 6x. Negative 6 times a positive 1 is negative 6 equal, there's another distribution, so it's 2 times x, which is 2x. 2 times negative 4 is negative 8, and then we have a plus 27. All right, now we want to combine like terms. Here we go. On my left side, we have like terms, which are the 9 and the negative 6. So I have a negative 6x here, but when I combine 9 and negative 6, that gives me a positive 3. Do you have to write it in this format? Not necessarily. If you wrote it as 3 minus 6x, it is still perfectly fine. All right. On my right side, I again have like terms. I have a negative 8 and a positive 27. So I have the 2x, and a negative 8 plus 27 is a positive 19. Now from there, we want to move the variable to one side. Now, it does not matter which side you want to move it to, as long as you get the variable that you're solving for all onto the same side. I like to keep my variables to the left, so I'm going to move my 2x. In order to move it, I have to do its inverse operation. This is a positive 2x, so to move it, I have to subtract. What I do to one side, I must do to the other. Notice that I lined up my like terms with each other. So negative 6x minus 2x is negative 8x, and then I'm going to bring everything else down. Plus 3, this cancels, and then I have 19 on this side. From there, now that I have my variable on the same side, I want to get rid of everything else by doing this inverse operations, focusing on my left side only. So minus 3. So I have negative 8x, and this gives me a 16. And then I'm going to divide by negative 8. So I have x is equal to negative 2. I hope this was helpful. Just a few reminders for this week's assignments. The password, make sure you submit it into the Google form that is attached with this video. Notes and practice problems. And dun, 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 there's no exit ticket and no purposeful practice. So everything is going to be due on Sunday by 11:59 p.m. So make sure you take great notes, make sure you complete the practice problems, and make sure you submit everything on time. Enjoy the rest of your day. Bye.